Well, friends, so now we have reached a very important chapter called as differentiation. Differentiation, as the name implies, it is nothing but differentiating a quantity with respect to the other quantity. It involves two variables. One is called as dependent variable, another one is called as independent variable. The variation of dependent variable with respect to the variation in the corresponding variation in the input variable, that is independent variable, is called as differentiation here. So we are comparing. For example, if you take y is equal to x, let us go to the whiteboard and start understanding this clearly. Yeah, in the whiteboard, now I'll go to, let us say, for example, you take, if I write, let us say, for example, y is equal to x. What does it mean? It means generally, if I write like this y is called as dependent variable. Y is in this function, y is dependent on what? On x. Very clear it is here. If you give x value 1, y also becomes 1. If you give x is equal to 2, y becomes 2. There is a linear variation. There is a linear variation. So I can say here that if y is changing, let us say from 2 to 1 or 1 to, sorry, x is changing from 1 to 2, y is also changing by from 1 to 2. So delta y and delta x, these are the main terms what we use. Delta y and delta x I'll write here. Delta x is called change in input or independent variable. Change in independent variable. What is delta y? Corresponding change in dependent variable. Corresponding change in the dependent variable. So if I write delta y by delta x, let us say like this, I am trying to compare the y or dependent variable with respect to the independent variable. This is called as differentiation. I will explain still further later in other slides and all. But condition is here, our delta x, the variation should be taken very, very small. That's why we put limit delta x tends to 0. This I'll explain when I'm coming to the subsequent slides. I'll explain. So main fundamental here is differentiation is a comparison between the dependent variable and independent variable. Now, to understand the differentiation, we have to understand the definition of slope. Slope of a given line, then slope of a given curve. So first I will explain to you the meaning of slope, which is directly related to the differentiation. Then I will solve the sums and pertaining to the differentiation side. Let us go to the first one. Slope of a straight line. I started with slope of a straight line. What is a straight line? A join of 2 points in the given coordinate system. Let us say A, B I have joined here. This is a straight line. This is also a straight line. Now, what is meant by slope here? Slope is nothing but with respect to A, how high this point B, if you know, you will get to know what is the slope of this. For example, in this case, you see A and B are in the same plane, same line. So that means B is not at all having any height difference with respect to A. with respect to a. So here slope of this line, if I want to know, it is a pakka parallel line. There is no difference at all. Means whatever coordinates, let us say if I write for a, I will write here x1, y1. If I go along the x-axis, this is let us say x-axis side, horizontal side. This one is vertical side. Then what is happening now? A is having a coordinate of x1. I am going straight towards B. B will also have y coordinate same because I am going parallel to the x-axis. But x coordinate may change. x2, y2 will come. x2, y1 will come. So y coordinate is remaining same. So now what is the height difference? Height means y coordinate difference. Generally when I say point B is with respect to A some units away. That means what? Let us say like this. With respect to A, B is here. So that means what? If you draw an horizontal reference line here, you will come to know what is the height difference. This is the height difference. Is it not? So now in this case, there is no height difference. In this case, there is a height difference of point B with respect to point A. This height difference is important now for us. Let us see how we will use this height difference to compute the slope of this line. So in this case, slope is 0. In this case, slope is there. We'll find out the slope of AB. Let us see what it is. Now we know here there is a line AB. Coordinates of A are x1, y1. Coordinates of B are x2, y2. Now, what is the height difference of B with respect to A? What is the height difference now? You clearly see here BC is nothing but the height difference with reference to point A. So, with reference to point A, with reference to point A, point B is at a height of what height it is now? BC. This is the height now. So what is the value of BC then? I want to know what is the value. Very simple. BC is nothing but total height BM minus CM. Sorry, correct, CM. So BM minus CM means what? What is BM? BM is nothing but y coordinate of B, that is y2. CM is nothing but the y coordinate of A. See, this is a line parallel like in this case. Top case you observe. If here it is y1, y coordinate of A, C also will have same coordinate x y1. So your y2 minus Cm will become y1. It is equal to the AL. AL height is nothing but the y1. It is parallel to Cm, therefore you can write Bm minus Cm is equal to y2 minus y1. Then what is the horizontal distance between A and C? B and B, if I want to call, it is a projection of AB on this. So AC I want to find out. AC will give me the projected distance of point B on AC. So that will become now, AC will become OM minus OL. It is simply OM means nothing but x2, x1. So now let us take the ratio. BC divided by AC. So y2 minus y1 divided by x2 minus x1. What is y2 minus y1? It is variation of y coordinates and it is variation of x coordinate. So that means you can write this clearly as delta y, that is difference of y coordinate divided by difference of x coordinate. So as explained in the previously, variation of y with respect to variation of x. So we are now differentiating y with respect to x. The meaning of this is that. So delta y by delta x is nothing but change in y with respect to change in x. Now, if you know the trigonometry, for example, this is a right angle triangle ABC. ABC forms a right angle triangle. What is tan theta? Tan theta is also called as BC by AC. This is now nothing but for you y2 minus y1 by x2 minus x1. This height. Okay. So this itself is called as now delta y by delta x. This is called as slope. This ratio is only called as slope. Slope of a given line is computed by finding out the ratio of the y coordinates change to ratio of the change of x coordinates, x2 minus x1. So this is the delta y by delta x is nothing but the slope. Now, since this is a straight line, if you take n number of points, let us say on this, slope remains constant. Remains constant. See now, for example, let me go back to this one now. Suppose y2 minus y1 by x2 minus x1. If this value is equal to, say, for example, if this ratio is equal to 1, what does it mean? It means that the function is linear. Function is linear. It is a straight line. Means you can predict the behavior of the function. If, on the other hand, y2 minus y1 by x2 minus x1 is equal to 0, then what? The function is a constant function. It is a constant function. So, if y2 minus y1 divided by x2 minus x1 is greater than 1, for example, then function behavior is computed from differentiation. Okay. So what did we understand now? We understood that differentiation is nothing but finding the slope. If you find the slope between 2 points, I'll be able to understand the variation of the one with respect to other. Dependent to independent variations we can find out. So this is a very important concept. Suppose if I am having a, instead of straight line, let us say a curve is there. I have taken a curve now, that is parabola. This curve I want to find out the slope. Where I want to find out slope? Let us say I want to find the slope of AB. Since curve is not a straight line, you will not get a constant slope. Continuously the slope will be varying. So if I find out, let us say by thinking that AB is a straight line, I will be ending up a wrong reading. Like for example, it will be like this. I am writing down this way. So if you join AB, I'll be computing the slope of a straight line AB rather than the slope of curve. So what I will do is, I will use the same formula y2 minus y1 by x2 minus x1, thinking that I am having a point in very close to A, and then get the difference of this ratio y2 minus y1 by x2 minus x1. For that, what I do, I will move this point very close to A, very close, infinitesimally small distance from A, and then apply the limit theory there and get the slope. Let us see how I am doing here. For example, we'll take y is equal to x square. And we wish to find out the slope at 1, 1. That is our idea. So what I require to find the slope, minimum I require one more point. So what I do, I will choose a point very close to A. Let us say 1.5. They are asking us to find at 1, 1. That means at the x value of 1. I do x value starting from 1.5. I will approach the 1, 1. So if this is the curve, let us say this is 1 comma 1. I will choose from 1.5 onwards. So when I choose 1.5, y will become y is equal to x square. That is the function I have taken. So I will find out in each case what is the y coordinate. 1.5 I have chosen, 2.25 I got. Second point I have chosen very close to B, 1.1. So I'm moving towards A, where my interest is there. I have to come to A. At A I will compute the slope. So 1.1. Next I will choose 1.005. So I have taken set of values very close to 1. Corresponding values of y I computed. So by using this equation, because they gave the function equation x square. So I have calculated the 1 point, this is 1.21, then 1.1025. Then what I do, I will find the slope between 2 points now. Between this, I will find out the slope. This is first point, this is second point. Slope between these 2 points, y2 minus y1. What is y2? This is, let us say, y2. y2 minus y1 divided by x2 minus x1. I got ratio 2.6. Again, I have taken between these two. Means I am moving this side. 1.21 minus 1.1025. Here 1.1 minus like this. Observe the table. 2.15 this ratio. So I continued my points. Then I found out slope between successive points, which are very close to A. A is fixed with respect to A, and then I am moving from B close to A. This is A for me now. Downwards is called A. I am coming from topmost point towards A. So when I am approaching very close to A, what I got last point I have taken very close to A, 1.00100, very infinitesimally small. What is the difference? Very small point. See 1.0. This is the x value. Sorry, this corresponding y is here. So I'm squaring this. Y is equal to x square will come. So 2.005 came. So as you observe here, 2.6, 2.15, 2.055, 2.0005, 2. Like that it is coming. So this means this value is very close. This is actually 2.055. Then next one is 2.005. Then one more zero you have to add here, this point. So it keeps on decreasing towards the 2. Almost it will be tending towards the 2. So that delta y by delta x now, for this, as delta x approached 0, it became, I will now write delta y by delta x is now tending to 2, as the difference is becoming smaller and smaller. That is called 0. Okay, are you able to see here? So I'll write clearly this point. As limit delta x tends to 0, delta y by delta x is equal to 2. So this is called as differentiation of, this is called as differentiation. What we did now is ultimately we did the differentiation of y is equal to x square at 1 comma 1. So the value of this has come to 2. So friends, hope you followed this particular thing. So whenever you are finding out the slope of a curve, you are supposed to differentiate the curve at point A by putting a limit delta x tending to 0 and approaching this point A from a nearby point, nearest point, which is infinitesimally away from it. Very small distance. That's why see 1 point triple 405 I have taken. It is a very small distance from 1. The difference between these two is further small. 0, 0, 0, 0, 0. 5 will come. That means ultimately I am choosing very close to the 1, infinitesimally small. That's why we are having liberty to write delta x tending to 0, not becoming 0 but tending to 0. This is the concept of differentiation from the slope. So friends, hope you followed this. In the next subsequent slides, we'll go further and understand the definition of differentiation from the very first principles. So now we learned from slope point of view. Slope is nothing but differentiation. Okay. Thank you.